definitions of infinite limits. I'm just going to put it up here instead of writing it out. Okay, so the definition is of infinite limits. So this uses that delta epsilon definition of limit. Okay, so let f be a function that is defined at every real number in some open interval containing c except possibly at c itself. The statement, the limit as x approaches c of f of x equals infinity. Okay, so c is the target value here. That's where your vertical asymptote is, right? Okay, so if we take the limit as x approaches that value c and we get positive infinity, then that means that I can pick any y value, m, and that is greater than 0. So I can pick any y value that is greater than 0, and then that means that there's a delta, which is the distance away from that target value or the vertical asymptote c, so that the y value f of x is greater than this m value that I chose. Okay? Whenever the distance away from the x value on this function and c, the vertical asymptote, when that distance is less than delta, then my y value is going to be greater than this value m that I picked. Okay? And I can then pick the m value to be bigger, and then I can find a y value that's closer to it as the x value gets closer into c. Okay? And likewise, if the limit goes to negative infinity, then you would just pick a number less than 0, and you could find something even more less than 0 than that. Okay? All right, so I'm not going to ask you to do anything with that formal definition of infinite limits, but just keep in mind that when we're taking the limit from the left and the right, as we approach that vertical asymptote, that is what we're finding there. Okay? All right. So if you look on page 109, definition of vertical asymptote, we already talked about it, but if f of x approaches infinity or negative infinity as x approaches c from the right or the left, then the line x equals c is a vertical asymptote. Okay, so that's what we were talking about, finding the vertical asymptote using limits. Okay, and then let f and g be continuous on an open interval c. If f of c is not equal to 0, g of c is equal to 0, then there exists an open interval c such that g of x is not equal to 0 for all x not equal to c in the interval. Then the graph of the function has a vertical asymptote at x equals c. So basically saying if this is not, where this is equal to 0 is the vertical asymptote, as long as there are values on the function that are in between that are not equal to c. So these values out here on the graph, so if this is your vertical asymptote, it's saying that's where your denominator is equal to 0, your g of c is equal to 0. Okay, and that is a vertical asymptote as long as there are values on the function that are not equal to that x value. So you have values greater than that on your function and values less than that on your function. Okay? All right, and then look at the properties of infinite limits. These are similar to what we have already talked about, properties of limits. Okay, so it's just saying let C and L be real numbers, let F and G be functions such that the limit as x approaches some value C of f of x is equal to infinity, and the limit as x approaches C of G of x is equal to L. Okay, so sum or difference, if I'm taking the limit as x approaches C of two functions, one of them is a constant, one of them is infinity, then when I add them together, I get infinity. Because something really, really big plus a constant is still something really, really big, right? Or something really, really small plus or minus a constant is still something really, really, really small, okay? Products, if I multiply something that has an infinite limit by something that has a constant limit, the answer, you take something huge, multiply it by some positive number, it's still going to be something huge positive. If you take something huge and multiply it by some negative number, then it's still going to be something huge but negative, okay? And then quotient, so this is taking the limit that is a constant divided by the infinite number. So that's like when we were writing out when you have a constant over something really small, or constant over something positive really small, or negative really small, then that's going to give you 0. Okay? Or I said really small, I meant really big. Constant over something really big is going to give you 0. Constant over something really small is going to give you negative, or infinity. Okay? Any questions on those properties of limits? Okay, let's look at some examples.